Welcome back, students, and we are going to start with abstraction data hiding today in Python. What abstraction and data hiding is the old school, object-oriented techniques and nothing else, right? And yesterday we completed inheritance, and today also I would like to show more about inheritance before we could move ahead with other object-oriented concepts, right? All right, so this is what we learned yesterday. So I'll continue with inheritance before I move to the next topic, which is going to be data hiding inheritance, right? The inheritance is I support complete, which is the new topic is going to be abstract classes, abstract functions, and also abstraction, right? To some extent, because the word private is a myth in Python, right? So we don't use it that often in Python. It's not famous for using private keywords and private variables, private member variables, or private methods of the class, right? But I will try and do something to at least justify, right? And do something to at least do justice to object-oriented programming in that matter. So, right? So before we get started, we still have something left in inheritance. I'd like to give you more about inheritance. So let's get quickly started with inheritance. And before I get started, I must congratulate all of you for coming so far, having the patience and having the guts and the will to come forward and being aspired to take forward the study of Python in your career, right? So let's get started. As I have already shown you about inheritance, right? So now I'll show you inheritance in a very different way. So for example, we have a class person. So a person can be anything, right? All right. So person can be a student, person can be a faculty member, both are persons, right? So that's why I've created whatever is let's say about common in faculty and student will go to person, right? So I will define constructor, which is init, right? And it takes 3 parameters or 2 parameters, let's say first name and last name, right? All right, so let's say self dot first name is equivalent to this first name. So whatever first name you pass when you create an object or the instance of the class will go to this instance variable, right? And we'll say self dot last name. You're declaring it right now, okay? Right? Now what is happening here is that you're declaring it at this moment in time. So this is called as declaration, right? You're declaring it right here, and you're declaring first name and you're declaring last name as an instance variable, and you're passing f name and l name, right? So the moment you make an object of the class, you have to pass these 2 arguments, right? So those arguments go into the instance variable first name and last name. So that's absolutely known. Now, for example, let's say we will define another function. I call this as print name, right? So the function name here is print name. So it takes only self. It doesn't take any argument, right? So it's just printing self dot first name, and it is printing self dot last name, and that's it, right? So no more funda here. So I'll say x is equivalent to person, or we can say, right? So x is equivalent to person. We have to pass arguments, right? So for example, if I pass NIIT and I will pass Sri Nagar, and I can say now, right, and I can call x dot print name, right? So now we should be able to get an ID Srinagar. So that's already known to you, so there's no funda here. So I just delete this instance right here. So for example, now if I create class, let's say about a student, right? It does not have any body if you don't want to define any body, right? Because it's going to throw an error if you don't define a body. You can clearly see unexpected right, indentation. So he's going to throw an error. You can see the code here, unexpected EOF while passing. You can see the mark here, yellow mark, right, it shows the error. And if you don't want to define the body, you can say pass, and now the error will not come, right. So now we have a class student and we have class faculty, right? And I'll say pass here. So let's say about if inheritance is not possible, if there is no inheritance, we may have to define this for student, because student may have first name and last name. Faculty will also have the first name and last name. So that means we'll have to redefine first name and last name. We'll have to define them again and again and again. So that, right? So that is why inheritance is possible here. So I'll make sure that the student inherits from person, right? So it's inheriting from person, and faculty is also a person, so it's also inheriting from person. So now if I say f is equivalent to faculty, and I will pass arguments now. Why? Because you have to pass arguments, f name and l name. Let's say, but if I pass it like this, it does not have its own in it, right? So I'll pass Fahim and I'll pass KHAN. What if I say f dot print name, right? So now you're getting Fahim Khan, right? Since it does not have its own constructor, so the moment you make an object of class faculty, it's inheriting from person. That means the super constructor or the constructor of the base class is called. I repeat, if the class does not have its own constructor being defined, so in that case, the constructor of the base class is going to be called. So you can clearly see you have created an object of faculty, right? Because it's inheriting all the private and public. It's inheriting all the properties and functions of person. Right, so the constructor is called, which is the constructor of person. That means the base class's constructor is called, right? Now, in case if I define its own constructor, so that's something else, right? So if I say f is equivalent to student, now you can see s is equivalent to student. I'll use the same right here, and I'm getting now. Right, so you are reusing it. Now, student can have its own properties. For example, if I create, I will say define init, right? So it can have its own properties, right? So I'll say self. And what are the properties that you expect a student to have? Roll number, right? Class, right? So these are own properties of I'll just say capital class. Right, so these are own properties of students now. So I will say self dot roll number is equal to, let me keep it roll r number, and let me keep it CLS class, CLE class, right? So self dot roll number is equal to r number, right? And second, I'm declaring another instance variable, so I will say self dot class is class is basically it's a keyword, so that's why it's coming blue, right? So is equal to CLAS, right? So whenever you call this, you pass class, that goes here, and yeah, every single thing is happening. So now it is there. It is the property, roll number in class is the property of student, and it's inheriting first name and last name from the person class, right? And let's go to faculty now. Let me just create another thing right here. So now let's say about FID, which is the faculty ID, right? And let's say about faculty ID, and let's say about what else can we give to faculty? FID, which is faculty ID. And I will give faculty, let's say about its own property, right? Let's say about QUA qualification. Your call means qualification. Let's make it FACID. Faculty ID is equivalent to FID. So we're assigning FID to faculty ID here, instance variable, and we are assigning this call to QUA qualification, as simple as anything, right? Fine, so now it's done. Now if I run it, now you can clearly see has no object attributed first name, right? You can clearly see this right here. Okay, right? So now you don't have to call print name, right? Now you can clearly see what is happening here. The moment I make an instance of the class student, right? So the arguments accepted here are not as that of first name and last name, right? Now the arguments accepted are, you clearly see roll number and class. That's what you are accepting in student, roll number and class. So now if there is no constructor defined, if you're not defined the constructor, right, inside student class, only then the constructor of the base class will be called. Now because you have defined the constructor, you can see arguments accepted are roll number and class. Now for example, if there is no class constructor defined, so I can say pass, for example, right? So if there is no constructor defined, so what is the argument accepted here? So what argument do you expect, right? What argument? You can clearly see F name and L name, because you're creating an instance of student, it's inheriting from person, and the arguments accepted are F name and L name, because now this is completely evident. This program is the evidence, or it's evident that if the class has its own constructor defined, right, it basically overrides and takes the param arguments for its own constructor rather than the constructor of the base class, right? Right, so that's what, when you add the init function, the child class will no longer inherit parents init function. Understand this. I repeat, when you add the init function in the child class, this is the child class, this is the child class, right? The child class will no longer inherit the parents init function. That means now not inheriting the init function of the parent, because you have defined its own init, so it does not, right? So in that case, if you want to inherit, right, so for example, to keep the inheritance of the parents init function, right, we'll have to add the call, or we'll have to call the parents init function. Now how do you call parents init function right here? So let me just go ahead. Now the name of the class is person, so I will call person.init, and now I can say self, right, F name and L name, right? So now I'm giving a call here to person.init. So this is basically a direct call to, what happened here? I suppose some kind undefined name, self, F name and L name. I don't know why is it undefined, so doesn't matter, right? So that way you can basically handle it. Now what I got to do here is now, right, I have to accept now, right? Now you can clearly see roll number is there, class is there, right? I have to accept now F name and L name. So the moment I accept F name and L name also, right, so out of everything that I'm accepting in this student constructor, now whenever I make an instance of student, right, class, I'll have to pass how many parameters? So let us see here, how many parameters do you pass? Roll number, class, F name and L name. You're passing 4 parameters, and out of 4 parameters, 2 parameters are going to the base class, right? So that is how it is possible now. So now we can just do the same here. All right, so I'll say self.roll number is equal to R number, and self.class is equal to class. So that thing is done. So let's go and execute it. Okay, we have to pass 4 parameters now. So for example, the first parameter that I have to pass is, you can even see it here, roll number class. So roll number is 100, so I'll have to pass class, I'll say 10th, right, and first name is equal to Fahim and last name is equal to Khan, Khan, right? Now you can clearly see 10th is not accepted, right? And now I can say s dot print name. Now you can call print name easily right here. So you're printing Fahim Khan, right? So now if you want to print full details, because now it should have its own function then, right? If you want to print anything more than that, right? For example, if I say define, right, print class, right? So you can take self here and you can say print, what do you want, right? So you'll say self dot roll number and you can say self dot class. So that's also possible, right? And I can say s dot print class. Now I'm calling print class here as well, right? Fahim Khan 110. Now you can clearly see. Now what is the benefit here? What is that I want you guys to understand and get it completely, is the fact that we are reusing first name and last name. You can clearly see we have basically printed and reused first name and last name for faculty, for student, and now we need to know, right, how to call the parent and the child constructor both, right? Because you can either call student or you can either call, because person is nothing, right? It's nothing. You have defined this class only to inherit, or only to make the child classes inherit these two properties. Otherwise there's no fun of this class. Even you don't want to create an object of this class, right? Do you want to create an object of this class? No. Why? Because this class is meant to be inherited. Like you can see inheriting, you can see inheriting, right? So this class is not meant to be or instantiated, but only created and creating an instance of, right? Okay, now what we can do, Python has also, or we can say now we have successfully added the init function and kept the inheritance of the parent class, and we are ready to add functionality in the init function also. Now we have understood parent and child both. Python also has a super function that will make the child class inherit all the methods and properties from its parent, right? So that's also there. So if you want to use, so instead of we using this person.int, right, we can use super. Super is a call, and this is a call to the constructor, which is as that of the base class. So super means you're calling the constructor of the base class. Now you can see 1, 2, 3, and 4. Now what will happen, you can clearly see here, the moment you create an instance of this student roll number class first name last name, so I'll say roll number class first name and last name. 3 position arguments, but 4 were given. Why does it take 3 only? Roll number class first name last name. Who gave 4? Okay, just a moment. What I need to do is something like this. Yeah, we don't need to give self here. Student object has no attribute roll number. Yeah, it does not have, sorry. So yeah, it does not take this self. Yeah, now you can see it has clearly done. Now you don't have to pass self here because you're not calling. You're calling directly. Super will not, basically super is going to make sure that the object is passed without self. Why? Because you're not calling basically this here directly by name. You're not calling person by name, but you're only calling the constructor of the person. So this is how we can call the constructor of the parent class, right? So what is super? Super is a function that will make the child class inherit all the methods and properties from its parent, including the init method. Super is basically, right, a call to the init method, right? So now you can add another properties and you can keep on doing this. So now second thing, that if I want to show you something, let's say about, I'll show you now inheritance is done. I'll show you a combined way, right? I'll show abstract class and inheritance in a combined way, right? Let's say about now, what is person? Person is nothing. We have only two classes. One is student and one is faculty, right? Person is nothing. Now, if I go and create an object of person, I'll say P, right? P is equivalent to person, right? And if I do this, right, I'm doing it well, right? So you can clearly see P is equivalent to person. Now I have to pass first name and last name. So it invalidates every single thing, right? Why are you even calling the person class? It invalidates each and everything, right? I can go ahead at the end and call the parent class, and that parent class will disturb each and everything of mine, right? You can clearly see. All right, so why are you calling? So there's nothing like person, right? We either have student or we have a faculty, right? Isn't it right? Yes. As I have shown you already. All right, so let's forget this super. So we don't want to call this super. All right, I don't intend calling this super anymore. All right, so what I want now is to, right, I do not want this class. So let me type this. So let me just give you in perspective. So it will be better if we, right, apply abstraction here. Now what is abstraction? Abstraction basically, let me write the full definition. It will be better if we apply abstraction here, because we do not want person class to be, right? So we do not want that person class to be instantiated, but only, right, inherited. So what I want is that my person class should not be instantiated. Instantiation means object creation. Object creation is done like this, P, right? So I can say P is equivalent to person. So this is called as instantiation, right? We're creating an instance of person class right here, right? So I do not want this, because this class is meant to be inherited. The class has nothing of its own, right? So that's what I write. Now we have to stop. So abstraction, what is the definition of abstraction? So or we can say providing, let's say about, how do you call that? I don't know. You can write relevant. So relevant is much better. So we can say providing relevant information outside the class, right, in an object-oriented system, right? So we don't want to provide, we only want to provide relevant information outside the class, right, in an object-oriented, or giving access to relevant objects and methods outside. So now you can see the first thing that we have to apply here is an abstraction. Abstraction is quite different here, because we do not have the concept of data hiding in private member variables here in Python. But yes, still abstraction is possible by giving the relevant information outside the class, or by providing relevant access, right? So I don't want to provide access to class person. I don't want this class to be instantiated, right? And for that, I'll first show you a small demo, and then we'll basically go ahead and complete this class. So I'll say, and we call this as abstract class demo, right? So I'll give you an abstract class demo here, and then we'll continue with this. I'll say abstraction. So I'll say this as abstraction. So now I need to provide you the demonstration of the abstract class. So for example, now what I do right here, to use an abstract class, we may have to use some annotations. Annotation like this, @static. We already know that, right? And to do that, what you okay, let me just keep it like this. Let me keep it like this. So what you got to do is you have to import, right, ABC. So what is ABC? Abstract class. ABC means abstract class. From ABC import, right, ABC capital, right? So ABC is basically a file which has many functions, and out of that I'm importing only one, which is ABC capital. What is that? Abstract class, right? And I want to import second thing from ABC, which is abstract, abstract method, right? So we have this abstract method now, and we have imported this abstract class now. So let's create class ACE, right? Or we can say class abstract test, right? So we call this class as abstract test, and this class is now going to inherit from ABC because we just imported ABC abstract class. So now we have to import it from, we have to inherit it from ABC. So let us create a constructor. So I'll say define init init and I'll take here some value. So I'll say self and or value. Some value you're going to take. I don't know what value you're going to take. Anything. I don't know. Right. So I can say self dot value is equal to val. Now let's say val. Right. So now we know that whenever I call this class, right. So I'll say AB. Let's say AB is equal to, right? So I'll say abstract, sorry, AB is equal to abstract test, which is the name of the class, and you'll have to pass one argument because the moment you create an instance of this class, init method is taking one argument, the constructor is taking a single argument, and you supply single argument, and it's running absolutely fine. So we don't have any problem right here. Right? Now a class should have a function wherein it does something, right? So for example, we have a class define print, right, me. So this is the function that we have defined, and the function is known as print me, and let's say it takes self, right, and let's say print self dot value. So this function is printing the self dot value. Absolutely right. So it's working absolutely fine. So why don't I go and call this class, call the function automatically here. I can either call it like this, ab dot let's say about we can call ab dot print me. So that's absolutely no problem. So you're getting 100 right here. Or what you can do, you can say self means within this class we have a function known as print me. So I can call this. So you can see 100 is coming automatically. Why? Because once you make an instance of the class, what do you call? You call init, right? 100 goes to here, and this init function is by default called, right? When you create an instance, that means you're at the time when you create an instance, you're calling print me. Or you can separately call it like this. So that's not an issue. You can separately call this right here. So it's going to do the same. Instead of self, I'll have to use the instance name or the object name, which is AB, and it's going to do the same thing for you, right? Okay. All right, now, so let's carry forward. Now what I do, I will mark, because I have imported abstract method right here, I will mark this as and decorate it with an annotation abstract method. All right. What we have been able to do is decorate this with an annotation abstract method. So now the moment I have decorated it with an annotation abstract method, now you can see you get an error. Cannot instantiate abstract class with an abstract method, print to me. Now what you have been able to do, you have been able to stop the instantiation of the class or the object creation of the class. Then you'll say, hey, why have we stopped the object creation of the class? I will say, hey, this class is not meant to be instantiated, right? If the class is meant to be inherited, right? So now, how, if the question is, how do you stop the instantiation of a class? Now, if it's a question, how do you answer this question? Right? How do you answer this question? Answer is that right, we need that class to, right, or we can say we first, right, have to import, right, ABC and abstract method from ABC, right? So that's the first thing that we need to do. Then we need that class to inherit from ABC, and right, and in order to stop or we can say this time object creation. That's the same thing, instantiation, object creation. In order to stop object creation or instantiation, we can say the same thing. In order to stop object creation, at least one method has to be decorated with at the rate of, right, at the rate of this abstract method annotation, right? And now second question is why, right? Question is, why do you need an abstract class? All right, so why do you need, or why do you require an abstract class? Must be more decorum. All right, so we need it when we, right, have the, or when we need it when, okay, so we can say when we move the common code into the base class, and we do not want, right, that base class okay. So when we move the common code or all the commonalities into the base class, and we do not want that base class to be instantiated, right? So, and we do not want that base class to be instantiated. That's a much better definition, right? Now you go back to your old class. Now you know that we have a class person, which is basically, right, designed as a base class, right? Why? To provide reusability of code. I do not want this class to be instantiated. Even if you instantiate, why would you? Because this class is meant to be inherited, right? Person is inheriting, student is inheriting person, that means it's inheriting first name and last name. Faculty is inheriting person, that means it's inheriting first name and last name, right? So once you are inheriting that first name and last name, it's not the first name and last name only. Tomorrow if you create some bigger application, some more complex applications, and those big and complex applications may have different things. They may have lots and lots of common code that you have to separate. You have to separate the common code, right? And then you have to create a single class that is going to handle the common code. For example, faculty has to log in. Faculty requires username and password, right? So I can go into person right here. So I can say, no need to actually pass it. For example, you can save memories. You can say self dot username, right? So you can say self dot password. Isn't it true? Right? So you want these things to be repeated, or you want them to be reused. I, as a programmer and as an object-oriented developer, I want to reuse them, right? So what I do right here, first things first, right? So as I said, I would do nothing, but I would apply abstraction here by just declaring the base class as abstract. Now, how would you do that? So I will say from ABC, which is an abstract class package. From package, it's something like this. From package, import a method, another method, abstract method, and I'll make sure the class person itself inherits from ABC, and I'll make sure that there has to, in order for the class, or in order that class to be abstract, in order to declare a class as abstract, it has to have at least one abstract method. So I'll say abstract abstract method. So the class is going to work as expected, right? Where is this? So what is this? Student print name. Have we created an instance of the class somewhere? Right? Student. Okay. Right. So, yeah, abstract class student with abstract method print name. What is print name? What is print name here? I don't know. Let me take it, let's say pass. Okay, we're defining another print class here. What is this? Alright, so let me just take it like this, pass and pass. Something has gone wrong. So let me create an instance. Now, current instance, I'm saying the student with abstract method, print name. So student is not abstract. Right, okay, we are just calling that, sorry. Pass. Just a moment. No problem here. Sorry. Okay, just a moment. Right. So now you can clearly see that it's not only that. Now you can see that you have to override this method right here. Okay, because you have to override this method in the derived class. It cannot be overridden unless you override this function, right? So that is why you cannot define the body of the function here. So I'll say pass. Right, or you can even say in class student, you can say define print name self, right, and I can say pass. Now you can see this, right? Okay, now int has two arguments. Now you have to pass two arguments, which is going to be Fahim and yes, KHA and right. So now it's started working fine. So now what we are going to do now, because you have to inside an abstract class, what we got to do, we always keep the common code or commonalities inside an abstract class. We will keep all the common code inside an abstract class. So that's what we want. So that way we're not going to define the body here because it's meant to be overridden. Overridden means it's meant to be overused. So I'll say pass, right? Now what is this? So let me show you here also. So we have already done it, right? So for example, this is abstract class test, right? Now it inherits from ABC. Why? Because you have declared is as abstract. Why? You don't want to create an instance of this, right? For example, now if we just, okay, let me make it more simple for you. Abstract class and one abstract method print me. So now the property of abstract method is that it should not have any body. Now the first thing, because this is meant to be reused, right? You want to reuse the function, you want to reuse the member variables, you want to reuse every single thing. So that way it should not have body. It's declared here and defined somewhere else. You're only declaring it here. What will happen if you declare it once? Doesn't matter how many times you call print b, it's going to use the same memory allocation rather than creating the new memory allocation for you. So for example, now I have class test, and this class test inherits from abstract test because we cannot create an instance of the class now, right? So you know that, right? So I'll say a is equivalent to abstract abstract test. I'll pass the value. Now you can see clearly right here. Okay, what happened? Wrong. Okay, we have it here. Okay, we have not closed this. Alright, so let me run it again. Now can't instantiate abstract class. Now you're getting it clearly here that we cannot instantiate an abstract class, right? Okay, let's go with class test. It inherits from abstract test, right? And now what I do, can I create an instance of this class now? Alright, so I'll say t is equal to test. No, I'll not be able to create an instance of this class as well. Cannot instantiate abstract class test with abstract method. Why? Now please read those words, or we can say note down these words, right, which I'm about to say. Note them down. I said a class is derived from an abstract class and it cannot be instantiated unless all of its abstract methods are overridden. Right? You may think that abstract methods can't be implemented in an abstract base class. This impression is wrong. An abstract method can have an implementation in the abstract class even if they are implemented. So, right, what I have to do now, because it has an abstract method, right? So I have to implement, because it does not have any body. The abstract method here does not have any body. I have to implement it here as well, right? So now I'll say define, but here it's only defined. Here it's declared only here. I'll define here. This is called declaration and this is definition of the body. So I will say hello. Alright, and let's say about we are passing one value here. Alright, so I can use here, okay, so I can use that self dot value. So you can say self dot value, so we can use that here. So now the moment I create it here, now we have to just, let's not create this, so let's say hello, right? So we have to pass argument, so I'll say 100. We have passed 100, okay, fine. Now what have you done is t dot print me, so I'll call t dot print me now. Now I'm getting hello. Now what do you want? You wanted to get hello plus self dot value, so you can get both hello and 100. Now you can see the main use of the abstract class here is right, to provide reusability. I can reuse this print function 100 and 200 times, right, and the amount of times that I want to use, and I will make sure, because I'm inheriting from an abstract class, right, which is abstract test, right, and I'm using this function print me, which means I will not have to redeclare the memory again and again. So I'll be using the old memory and old instance. Doesn't matter the number of times I call the class. I can now create another class, and I can now go with the same thing, right. Now let's do the same here. Okay, as I said, the abstract method will not have the definition here. The definition will be in the student class. So I will say print, and I will use self.fname, first name, and self.last name. So this is coming from the parent class. Now you can see this is the child class inheriting from person, which is an abstract class, right, and you're calling student, and then everything is fine. Now you can clearly see, right. Now if you want, you can say s dot print name. Now you can see Fahim Khan, you're getting the name. So it doesn't matter, right. So you have to basically take a note of this also, right. And I will note down one important point for you here, right. So as I said, that you may not be able to implement it unless, right. So I'll say, okay, I'll write it down for you. So whatever I said, so a class that is derived from, right, a class that is derived from an abstract a class that's derived from an abstract class cannot, so cannot instantiate or cannot be instantiated unless all of its abstract methods are overridden. Now what is overridden? Overridden is defining something that's already declared. You are declaring it in the base class person, and you are defining it in the student class. That means you're not using double memory. Print name and print name will point to the same memory location right here, right. Even if you use it in the third class, it will still point to the same memory location. So this is memory management for you. Let me take a look at timings. I know that you're not going to get it at once. I'll have to maybe show you 2 times or 3 times continuously and consistently in order you to understand this abstraction. This is the most important topic, encapsulation abstraction. I'll try to teach you 2-3 times so that you get it. Do not worry at all. Even if the first class has given you or this class has given you an idea of, let's say, about 40%, 50%, 60%, so that's quite sufficient for you. All right. Abstraction and encapsulation often takes time and understanding along with polymorphism. It's not something that you're going to get at the first go or in the first class. You are going to get a bit confused, right. So the confusion is going to make you actually learn and research the concept. So right, so tomorrow's class will also be about inheritance and abstraction and encapsulation. So you need not to worry about anything that is not shown to you guys, or you need not to worry about anything that you have not understood, right. But yeah, it is basically very clear that there are going to be commonalities. For example, if I am making a register screen, if I'm making a software for school, right, so I have to give access to faculty, I have to give access to admin, I have to give access to students, right. So in that matter, each and everyone, as faculty has a first name and last name, username and password, mobile, email, right. A student has first name, last name, mobile, email, right, address. So those are the things which are reused, right. Instead of redeclaring them and overusing the software resources like RAM, CPU, if we reuse them, so we are going to do we are going to do very good, or we are going to do just with object-oriented programming. So unless, right, there are many programmers, around 70% of whom I know, they use object-oriented programming like C, like any other non-object-oriented programming, and they consume a lot of memory, right? And they consume a lot of server resources. So that's not software development. You'll develop a software tomorrow and say, hey, my software requires 300 gigabits of RAM. So that's not a software, that's a garbage, right? So please and please practice very hard and just wait for the next lecture. In case if you still have confusions, no problem, that all the confusions I'll try and clear in the next class, inshallah. I wish you all the best for the next class. Do practice and let me know if I can help you down in the comment section. Bye bye, take care.